Hi students, this is the review for your spiral number 2. For the first question, we're given a function that has a domain and a range that are really specific points. That means that we can't use any numbers between these, so I'm just going to kind of arbitrarily decide to actually make these points. You can do this in any order that you choose, but in mine I'm going to go -4 to -6, just because those are the first numbers in the domain range. 3, 4, the second numbers, 5, 5, and 9, -2. Any combination of those would be totally fine. So when I graph those, so we've got -4, -6, we've got 3, 4, we've got 5, 5, and we've got 9, 2. Oops, sorry. Should be 9, -2. Okay. If I wanted to add 1 point to make this no longer a function, I could add something like this so that it fails the vertical line test. Right. Problem 2, although the numbering here is going to be totally crazy, we've got this relation, and the first thing we have to do is identify the domain and range. There are a couple things that I'm going to take a look at. The first is that our graph stops before it goes off the grid in both places. That means for my domain, we have a starting value going from -2, and we have an ending value of 5. That's the lowest and the highest x value. I'm going to put brackets around those because both of those points are included. This is the same thing as saying -2 is less than or equal to x is less than or equal to 5, or all the numbers between -2 and 5. The range, the same thing. I'm going to look for my lowest y value. That's going to be at -1. I'm going to look for my highest y value. That's going to be at +5. And I'm going to put brackets around those because we include both points. That'd be the same thing as saying -1 is less than y is less than 5. And again, either of those versions are totally okay to use. Must this relation be a function? This relation is a function, and it's because it passes the vertical line test. There's no vertical line I can draw that hits two different places. Alright, for the next question, we're doing some function stuff. I'm finding g of f of 4. That means I've got to find f of 4, which in this case is going to be 5/9. And I'm going to plug that into g. So g of 5/9. That's the square root of 1 minus 5/9, which is the square root of 4/9, because 1 is 9/9. I can take the square root of that. Square root of 4 is 2. Square root of 9 is 3. This fog notation is the same thing as saying f of g of, and then we've got x squared plus 1. Oof, this is going to be kind of a mess. I'm going to do the inside first because we go from inside out. So we've got g of x squared plus 1, which is the square root of 1 minus x squared plus 1, and I think I remember there being an issue here, and there definitely is going to be an issue here in just a moment, so I apologize for that, although we can kind of deal with that. Anyway, so when we do that, I'm going to simplify that to be 1 minus x squared and then minus 1. My 1's cancel out, leaving me with the square root of -x squared. I want to take you through a little bit of logic here. X squared is always positive. If we make a positive number negative, we end up with a negative inside a square root, which gives us a non-real answer. So that's that I stuff that we were looking at. Because of that, we're not going to continue going through here. But if we were, we'd be then plugging this into x to get a combination of these things. I remember when I wrote this problem a couple years ago that this came up, and I forgot to change that between years, because it's been a couple years since I've had this on a spiral review. All right, we've got some messy problems, but the goal here for me really is to show that these are not as scary as they look. These are working from the inside out. So I'm going to find g of 2. G of 2 is 2. And then I'm going to go one layer out and find f of 2. F of 2 is also 2. And then I'm going to go one layer out and find h of 2. H of 2 is 3. And then my last layer, g of 3, is g of 3 is 3. And that's it. So g of h of f of g of 2 is 3. All right, then we've got to find the next one. Again, I'm going to kind of work from the inside out. H of 0. So I'm going to change colors here. H of 0 is 1. Take a layer out. G of 1. G of 1 is 2. Go another layer out. F of 2. F of 2 is 2. And then we're going to have that last layer 2 times, we got the answer 2, plus 3, which is 7. Next up, we've got transformations. And when I look at this graph, I've got a number of different transformations that are being done here. So looking kind of carefully at the various transformations that are happening, because we have 4 different transformations, which is a lot. I'm going to do the y stuff first. So I'm also going to kind of identify these 4 important points, and I call these important because they are where this graph has easy things to identify. So we've got, this is -2, -1. This is at 1, 5. This is at 3, 3. And then we've got this one at 5, 3 also. That's right, 5, 2. Okay. So when I'm talking about this, I'm going to write down my original y values. So that was -1, 3, and 5. Those get all 3 of my y values. And then I'm going to look at my transformations. I'm going to underline the y parts in blue. The first thing I see is that we've got to multiply by -1. And then we've got an add 3 at the end. I do them in this order because of order of operations. That makes it so that we have we have y values that are transformed in both of those places. So -1 multiplied by -1 is +1, and then we add 3 would become 4. 3 multiplied by -1 is -3. Add 3 becomes 0. 5 multiplied by -1 is -5. Add 3 becomes -2. Okay, those are my y values. For my x values, the way that I find easiest is to set up this as an equation with all the old x values. So the old x values were -2, 1, 3, and 5. And for each of those, I'm going to set that equal to 2 times x minus 1. All right, so if I've got -2 is equal to 2x minus 2, adding 2 to both sides, dividing by 2, gives me x equals 0. For 1, let me put this over here so that I have a little bit of room. If I add 2 and then divide by 2, I get x equals 1.5. 4, 3 is equal to 2x minus 2, and that's just distributing this stuff so I don't have to do that every time. If I add 2 and then divide by 2, I get x equals 2.5. And for 5, the same thing. If I set it equal to 2x minus 2, if I add 2 and then divide by 2, I get x equals 3.5. All right. Looking at these, I'm going to now combine them. So negative 2 for the x went with negative 1 for the y. That point is now 0, 4. 1, 5. There's my y value. There's my x value. Is 1.5, comma negative 2. 3, 3 is going to be 0, comma 2.5. And 5, 3 is going to be, sorry, just totally screwed that one up in terms of the x and the y. 2.5, comma 0. And then 5, 3 is going to be 3.5 and negative 2. And I also screwed that one up for the x and y because I looked for the 5. Sorry, 3.5 and 0 because the y used to be 3. So wondering why that had a different value. Okay. So 0, 4. 1.5, comma negative 2. 2.5, comma 0. 3.5, comma 0. There's my new graph. What I would like you to notice is that this thing has been flipped vertically. It's been moved up 3, although that one's kind of hard to see. It's been squished horizontally by a factor of 2. That's what's going on here. And then it's moved to the right 1. But again, with the squish, that's hard to see. This is a significantly more difficult transformation than anything that you'll be asked to do on a spiral. Here you're asked to do 4 out of 4 possible transformations. I'm generally looking at about 2, and I also will avoid using this one because that makes it much harder for us. All right, same thing. Here we've got, oh no, this is not transformation. This is back to function stuff. So we've got the graph below for f of x. G of x is 3x squared minus 8. F of 3 is asking us to find the height of the graph at 3. That's 0. G of negative 3 is going to be 3 times negative 3 squared minus 8. That's going to be 27 minus 8 is 19. F minus g of 2 is the same thing as saying f of 2 minus g of 2. So f of 2 is going to be 1. And g of 2 is going to be 3 times 4 is 12, minus 8 is 4, negative 3. F of g of 1, I'm going to find g of 1 first. So it's going to be 3 times 1 squared minus 8 is negative 5. F of negative 5 does not exist on our graph. Find all values of k such that f of k is 0.5. Okay, that's talking about this graph, and this means the height is 0.5. I'm going to draw my line across at 0.5. That looks like 1.5 and 2.5. So k equals 1.5 or 2.5 to have a height of 0.5. Here's another transformation. This is much more similar to what I'd expect you to do. In terms of a couple of points that I could use for this, I've got the vertex. That's always a really important point. So that's 0, 2. I've got negative 2, negative 2. And I've got 2, 2. I'm going to do my x stuff first, just because that's a little bit easier. So I've got x minus 2 equals 0. That gives me an x equals 2. I've got x minus 2 equals negative 2. That gives me x equals 0. And I've got x minus 2 equals 2. That gives me x equals 4. I'd like you to also notice that we can think about this geometrically. In all three cases, these moved 2 units to the right. For the y stuff, I've got to multiply by negative 1. I'm going to say mult by negative 1, so it doesn't look like an x there. And then I've got to subtract 1. I'm going to rewrite that because that's completely illegible. So multiply by negative 1, and then subtract 1. So that becomes negative 2 minus 1 is negative 3. Negative 2 becomes 2. Minus 1 is 1. And then 2 becomes negative 2. Minus 1 gives us minus 3. Okay, so 2 comma negative 3 is going to be our first point. Oh, nope, that's not 2 comma negative 3. That's 2 comma negative 3. There we go. Then we've got 0 comma 1 and 4 comma negative 3. 4, negative 3. And if that graph looks really funny to you because it doesn't have the same shape, you may have noticed earlier, Mr. Carlson, you screwed up. That should be negative 2, and you wrote positive 2 instead. That's going to change our last value from negative 3 to become positive 1 instead. So my last point is not going to be there. It's going to be here, which gives us a parabola that looks like this. All right. In terms of the transformations, we have flipped it vertically and then gone down 1, and we have moved this 2 to the right. One more transformation. Wanted to give some extra practice on these this week since it's the last time that we're going to see this as a spiral topic. So we've got to do a couple of different things. The first is to sketch this graph. Same thing that we've been doing. I noticed that the x stuff is going to, I'm just going to do this part in purple, shift 1 to the right. This one I'm going to do just kind of visually and see if that works for me. So if I were to shift this graph to the right by 1, I would end up with a graph that looked something, in fact, exactly like this. This is my shift 1 to the right graph. The next thing I'm going to do is to multiply all the y values by 2. So that would stay the same, that would go up, that would stay the same, that would go down, that would go down, that would double and become negative 4. Negative 3 would become negative 6, which is going to be somewhere down here. And what I'd like you to notice is that after 2 transformations, my graph has now moved and has become steeper. My last transformation would be up 2. So we'd go here up 2, here up 2. There's my up 2. And now we're actually on the graph there. Cool. So the blue graph is the final graph that we're looking for. I'm going to color that in a little bit darker just so we can kind of notice that that's the final one. And for any of those points, I kind of did that step by step to make it a little bit easier for me to process. That's an alternative to using kind of the table format or kind of the equation format for either of the previous two. Find m of negative 2. All right, that's the blue one. That's negative 4. Find m of 4. That's the blue one. That's going to be at a height of 2. Next up, we've got some complex numbers. These are the first time that we've seen these on a spiral, and they're going to be paired up. You're probably going to have 2 of these, not 8 to do. So for the first one, I'm looking at this as negative 2, and then I'm going to combine those two. Minus 2 times negative 3 is negative 6, I squared. I know that I squared is negative 1 plus plus. This is going to be negative 2 plus 6 times negative 1, which is minus 6. That's negative 8. For number 2, I'm going to rewrite this negative 5i minus I times 3i is 3i squared. I squared is negative 1. So this becomes negative 5i plus 3, which we tend to write as 3 minus 5i, but it doesn't matter. For the next one, we've got negative 4i times negative 5 is going to be 20i. And then negative 4i times negative I is going to be minus 4i squared, which is plus 4, because I squared is negative 1. So we got 20i plus 4, which we tend to write as 4 plus 20i. For the next one, we've got negative 5 times 5 is minus 25. I times I is I squared. I squared is negative 1. That makes that positive 25. And then plus 3i is nothing to combine with, so it's plus 3i. For number 5, we're adding between, so I'm going to add like terms. Negative 4 plus negative 5 is going to be negative 9. And then 5i plus 3i is going to be 8i. For number 6, we've got adding again. Negative 1 plus negative 4 is going to be negative 5. And 3i plus 2i is going to be 5i. For number 7, we've got multiplication, so we've got to do some distribution. We got positive 8 plus 2i plus 12i, and then plus 3i squared. Reminder that that's negative 1. So when I combine like terms, I've got 14i for my I pieces, and then this becomes negative 3. 8 plus negative 3 is 5. For the next one, I'm adding again. 1 and negative 1 is 0. Negative 2 and negative 3i, that's going to be negative 5i, and that's it. The other new stuff is based on graphing polynomials in factored form. There are a couple things that we need to know here. We know that we can find x-intercepts. There's going to be 1 at x equals 2. I'm just going to keep going with the positive ones. It's going to be 1 at x equals 5, so 3, 4, 5. And there's going to be 1 at x equals negative 1. I can also find my y-intercept by plugging in 0. So we've got 3, 0, I need to erase the parentheses, minus 2 squared, 0 plus 1 squared, 0 minus 5. That's going to be 4, so 3 times 4 times 1 times negative 5 is going to be negative 60. And then I've got to look at my powers here. Whenever we have a second power, that's going to be a bounce. So we've got a bounce at negative 1 and a bounce at 2. I like starting these from the y-intercept, because then if I go up here, I see I've got a bounce. I've got to go through that, and since there's not a bounce, I'm just going to keep going in that direction. Same thing as I come back. I'm going up here, I hit my bounce. No other places to cross over, so I'm just going to keep going. At this point, that is done. Same thing. We're going to identify 3 different x-intercepts at 3, at negative 3, and at positive 1. The y-intercept is going to be at 0 minus 3 times 0 plus 3 times 0 minus 1, which is going to be 9. I want to say that should be like there. Okay, none of these have powers bigger than 1, so we're just going to do pass-throughs in all 3. I pass straight through, I pass straight through, and now I've got to go back up to hit this and just kind of keep going. We don't have a good way to show, in fact, this probably is not the peak of this graph, but without using technology, we don't have a good way to do that yet. All right, same thing. I'm going to identify my zeros. We've got positive 2, we've got negative 2, and we've got negative 6, 2, 4, 6. I want to remind you that things that are power of 1 pass through the x-axis. Things that are power of 2 bounce off the x-axis. Things that are power of 3, they pass through, but they hesitate first. So for the x plus 2 root, it's going to have this hesitation here. I'm going to write hes for hesitate. I'm not quite sure how the rest of this graph is going to look, so I don't want to do the directionality of that yet. I've also got to find my y-intercept. That's going to be at 0 minus 2, 0 plus 2 cubed, 0 minus 6. We've got negative 2 times 8 times negative 6, which is going to be positive 96. I'm just going to put that here and call that 96. Okay, so now as I go through here, my hesitation looks like that. I'm going to pass back through here. Because there's no power bigger than 1 there, it just keeps going. Same thing on as I go to the right. This is something is going wrong here. And I'm trying to figure out what that is. And that's because this should be negative 96 and not positive 96. Oof, I'm glad I write problems down wrong all the time. So let me erase the picture so far. I apologize for that. I'm going to put my lovely negative 96 down below, so that way we're going up and to the right. We've got to hesitate here. That's a terrible looking picture, and we're going to go down there. I recognize that this was wrong because I know this is a positive graph, and my graph was about to go down instead of up as I go to the right. That's how I figured out that I made a mistake. Doing the same thing, I'm going to identify all the zeros straight away. We've got a 0 at 2, and I'm going to write bounce there. That's also my y-intercept, so I don't need to recalculate that. At x minus 2 gives us plus 2, x minus 7 gives us plus 7, and x plus 1 gives us minus 1. Okay, now I've got to use that negative because I can't go for my y-intercept. The negative out front means that we're going down to the right at the end. And now I'm going to trace a nice smooth curve here. I'm going to go through that, bounce off, and go through. And it's going to look something like this. Same thing, but working backwards. This problem is a much more complicated one than anything that you're going to see on our spiral, just in terms of the number of things that are going on here. So at negative 7, I've got a hesitation. That means I'm going to have x plus 7 to the third power. At negative 3, I'm going straight through. That means we're going to have x plus 3 to the first power. At 0, I'm going straight through. That just gives me an x. And at 1, we are bouncing. So that gives us x minus 1 squared. Because the y-intercept is going to be 0 as well, we don't need to worry about any number out front for this. All right, same thing's going on here, but this time we have descriptions instead of a picture. Roots at x equals 2 with multiplicity 1. Okay, so that's going to be x minus 2. X equals 5 with multiplicity 3. X minus 5, power 3. X equals negative 4, multiplicity 2. So that's going to be x plus 4 and power of 2. If I were to sketch this thing, so we're going to have positive 2, 3, 4, 5, 1, 2, 3, 4. We know it's going to rise to the left, so that means that over here it's going to go up. I'm going to bounce at negative 4. I'm going to go straight through at 2, and at 5 I'm going to hesitate, before continuing going through. I notice that my graph goes up and to the right at the end when I do this. That means this is going to be positive out in front.